The topic for Lesson 4.4 is equations as relations. You'll learn to use an equation to determine the range for a given domain and graph the solution for a given domain. They ask, why are equations of relations important in traveling? During the summer, Eric will be taking a trip to England. He's saved $500 for his trip and wants to find how much that will be worth in British pounds sterling. The exchange rate on that day was $1 was 0.69 pounds. Eric can use the equation P equals 0.69D to convert dollars to pounds. The equation P equals 0.69D is an example of an equation in two variables. A solution of an equation in two variables is an ordered pair that results in a true statement when substituted into the equation. For our first example, they ask us to find the solution set for y equals 7 plus 3x, given the replacement set -5, 0, -3, -2, 2, 13, and 4, 19. This table shows all the work they did. I would not make you write all of this out. They are substituting in -5 for x and 0 for y and seeing if they get a true statement. 0 does not equal -8, so that's a no. For -3 and -2, -2 does equal 7 plus -9. 13 does equal 13, and 19 does equal 19. So the answers are the ones that work. So the ones that have true after them are going to be our answers. So -3, -2, 2, 13, and 4, 19. For example 2, they switched it up. They said solve D equals 8 minus C if the domain is -2, 0, 3, 5, 8. In a perfect world, they'd stick to x and y, but we don't live in a perfect world. So when the variables other than x and y are used in the equation, we're supposed to assume that the letter that comes first in the alphabet is the domain. X comes before y, so on number 2, C comes before D. So they gave us the C values, the domain, and if we substitute in 8 minus -2 is 10, so we'd get the ordered pair -2, 10. 8 minus 0 is 8, so we get the ordered pair 0, 8. 8 minus 3 is 5, we get the ordered pair 3, 5. 8 minus 5 is 3, so our ordered pair is 5, 3, and 8 minus 8 is 0, so we have the ordered pair 8, 0. If we used the braces and listed out our solutions, it's the same thing that's in the table. -2, 10, 0, 8, 3, 5, 5, 3, and 8, 0. Huh, interesting. I wonder if is a reason they have two of those that are inverses of each other. You can graph the ordered pairs in the solution set for an equation in two variables. The domain contains the values represented by the independent variable, which is usually x, and the range contains the corresponding value represented by the dependent variable, which is usually y, or whatever comes second in the alphabet. Example 3, they ask us to solve the equation 9x plus 3y equals 15 if the domain is 0, 1, 2, 3, and then graph it. So it would be convenient if that were solved for y. So I'm going to subtract 9x from both sides of the equation. And divide by 3. So y equals 5 minus 3x. And so I solved for my dependent variable in terms of my independent variable. And we take that expression and we're going to replace x with what x equals. So if x is 0, 3 times 0 is 0, 5 minus 0 is 5. If x is 1, 5 minus 3 is 2. If x is 2, 5 minus 6 is -1. And if x is 3, 5 minus 9 is -4. So there are our 4 ordered pairs. And now we get to plot the points. So we have 0, 5, 1, 2, 2, -1, and 3, -4. Looks like they formed some sort of a pattern. In 2002, 12 countries in Europe made the switch to a single currency, the euro. Suppose the exchange rate between US dollars and euros is $1 equals 1.11, euros. The equation E equals 1.1D can be used to convert US dollars to euros. If a traveler is going to spend the following amounts per day while in Europe, find the equivalent US dollars for the amounts given in euros and graph the ordered pairs. Our equation is solved for euros, given dollars, but we're given euros, I'm supposed to get dollars. So I'm going to divide both sides by 1.11. So D equals E divided by. Now if I take 1 divided by 1.11, it's really close to 0.9. It's 0.900900901. So they just use that as their conversion rate, and then that's easy enough on the calculator. 0.9 times 90 gives us $81. 0.9 times 50 is $45. 0.9 times 30 is $27, and 0.9 times 20 is $18. Once we've got the points, it's easy enough to plot them. They made the scale going by 20s for both the dollars and euros, and then we're just plotting 90, hello, 90, 81, should have been a little bit closer to the 80. And then we had 50, 45, that one's pretty good, and 30, 27, and 20 and 18. Seems to be a pattern here as well. In the equation involving x and y, the set of the x values is the domain, corresponding set of the y values is the range, and we can use them to graph and find lots of predictions from our equations.